Greetings everyone. Welcome to the exploration of machine learning with ThinkNix technologies. In our previous video, we navigated through the intricacies of artificial intelligence. In this tutorial, our focus shifts to machine learning, a potent technique within the AI domain. Let's delve into the capabilities and insights it offers, shaping the landscape of technology. Get ready as we explore the nuances of machine learning together. Now let's have a look at the agenda for the day. Unveiling the fundamentals and essence of machine learning, exploring the foundational principles associated with ML, categorizing and comprehending the various types that ML encompasses, examining the diverse domains where machine learning is actively applied and making a significant impact, delving into the challenges faced and essential insights to consider when working with this transformative technology. Imagine you have a friend who loves recommending movies. Initially, you share your favorite films and they start understanding your preferences. Over time, they notice patterns such as the genres you enjoy or your preferred actors. As a result, when a new movie is released, your friend can make informed guesses about whether you'll like it or not, drawing insights from your past preferences. This concept is similar to how a machine learning system learns from data to make predictions. In essence, machine learning is a subset of artificial intelligence, as discussed in our previous video, which is accessible through the link provided in the description box. It involves leveraging data and statistical algorithms to simulate human behavior. Essentially, machine learning empowers computer systems with the ability to learn autonomously without the need for explicit programming. Before delving deeply into machine learning, let's explore the fundamental concepts associated with it. In machine learning, a feature represents an input variable, often denoted as the X variable. A simple ML project may use a single feature, while a more complex one could involve millions of features. On the other hand, labels are the output variables, denoted as Y in the context of machine learning. For instance, a machine learning project predicting real estate prices could include features such as location, square footage, and number of bedrooms, while the label to predict would be the price of the estate. Understanding the concepts of training and test data can be likened to preparing for an exam. During the training phase, similar to studying from a textbook and solving practice problems, a machine learning model learns from a set of examples known as the training data. On the day of the exam, when you encounter new, unseen questions, corresponds to the test data for a machine learning model. The test data helps evaluate how well the model can apply its knowledge to novel situations. Consider the scenario where you are determining house prices based on their size. A model in machine learning is analogous to a knowledgeable friend who informs us about the correlation between the cost of a house and its size. The model essentially captures and represents the underlying patterns within the data. Moving forward, we'll explore three distinct types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Now let's take a closer look at each of them separately. Supervised learning involves instructing a computer through the presentation of labeled examples, analogous to guiding a child in learning colors, by providing them with images depicting various colors accompanied by their clear identifications. In the realm of computing, the process involves providing the computer with pairs of examples, consisting of input and output, to streamline pattern learning. The objective is to enable the computer to excel in recognizing these patterns, ultimately leading to accurate predictions when encountering new, previously unseen examples. Let's delve into unsupervised learning by taking a straightforward example. Imagine sorting a mixed bag of colored balls without labels. Unsupervised learning would group them based on shared characteristics, discovering relationships among different colors. Instead of being explicitly told what to focus on, the computer figures out patterns within the data, even in the absence of specific categories or labels. Unsupervised learning encompasses the training of a model using unlabeled data, where the input lacks the necessary output features. It pertains to the identification of patterns and structures within data in the absence of predefined categories or classes. Reinforcement learning, also termed as reward-based learning, is the most practical form of learning where machine derives insights from its decisions. It involves the fundamental concept of feedback, wherein correct decisions yield rewards or positive feedback, while incorrect decisions result in penalties or negative feedback. Analogous to the training of a pet, this methodology emphasizes the learning process through consequences. Moving beyond theoretical concepts, let's explore how ML integrates seamlessly into our daily lives. Customer service. AI, powered by machine learning, is revolutionizing customer service by introducing automated processes like chatbots and virtual assistants, enhancing operational efficiency, ensuring timely responses, and 24/7 availability. Predictive and sentiment analysis enabled by machine learning helps in better understanding and addressing the customer's needs and requirements. Computer vision. This remarkable technology empowers computer systems to extract meaningful information from digital systems, videos, and other visual inputs. From self-driving cars to advancements in radiomics, computer vision is transforming how machines perceive and interact with the visual world. Recommendation engines. Leveraging machine learning and analysis of past consumer purchasing patterns can reveal valuable trends. Recommendation engines are being used by online retailers to make relevant product recommendations to customers during the checkout process. Fraud detection. Banks and other financial institutions have been using machine learning to spot suspicious transactions. Anomaly detection can identify transactions that look atypical and deserve further investigation. While this field of ML holds immense potential, it does not come without hurdles. Let's explore some of the key challenges together. Commencing with the challenge of data quality and quantity, ML models rely heavily on high quality and sufficient data to function effectively. Inadequate or poor quality data can lead to biased models and inaccurate predictions. Transitioning to privacy concerns, machine learning, especially when dealing with vast amounts of personal data, can raise valid concerns about privacy, potentially revealing sensitive information or reinforcing biases. There's a risk of unauthorized access and manipulation of this technology. Moving forward, we encounter overfitting and underfitting. Overfitting occurs when a model learns the training data too well, capturing noise and making it perform poorly on new, unseen data. Underfitting, on the other hand, happens when a model is too simple to capture the underlying patterns. Striking the right balance is the key. Addressing scalability issues, machine learning involves challenges associated with the demanding computational resources required to train and deploy models and the increasing memory requirements linked to data growth and expansion. In summary, machine learning takes us into the exciting world of computers learning on their own without explicit programming. The ever evolving landscape of machine learning continues to shape the future of technology and human interaction, but it is necessary to ensure the ethical and responsible integration of this powerful technology into our lives. Thank you for watching. If you enjoyed this video, please hit the like and subscribe button. For more details about ThinkNext technologies, check out the link below. Stay tuned for upcoming videos and updates.